In this session, let us understand what are draft system or drought and what are the need of the drought system in thermal power plant. So initially, to know what is drought system or a draft, it is nothing but the flue propagation, means it is something connected to the flue passage. The flue gas propagation is a process of movement of the hot gases, right? It has to pass through number of different boiler accessories like economizer, where it has to exchange heat with the incoming water, air preheater, where it has to exchange the heat with the incoming air, and finally it has to go to chimney. If the boiler is provided with the electrostatic precipitator, then it has to pass through that also. So the function of the draft is to supply the required quantity of air for combustion, propagation of the flue gas, and remove the flue from the system. It is mathematically it has been defined as a difference in the pressure, right, between the pressure of the air in the fuel bed to the flue gas. So if the pressure is there, the difference in the pressure is there, then only we can get a constant flow of a flue gas passage or propagation. How it is achieved? Yes, we want a different structure to achieve this one, and this is achieved by chimney, right? The other name is stack. The most common method to achieve this difference in pressure of draught or draft is to provide by chimney. The chimney is a hollow structure, right? It is to make the flow of flue gas very easily through it. The chimneys are made up of steel, brick or concrete. Bricks and concrete chimney are generally used as they have a longer life. The thing is, the flue gas which are produced may be sulfur in nature, right? When we are giving excess air to this one, the sulfur dioxide will become to sulfur trioxide, and because of the dew point in the chimney, right, this water with the sulfur trioxide will become sulfuric acid. Hence we have to take care the material that we are using, and it comes into picture when I take what type of fuel into my combustion. If my fuel is having sulfuric or sulfur in its composition, then surely I have to take extra care. And the average life of the concrete chimney is about 50 years. Anyhow, it has to be maintained in a proper. In the steel work we can make a patch up, but if the brick work is there, we have to either do masonry work during annual shutdown. The life of the steel chimney is about 25 years, which depends upon maintenance and care to be taken to prevent corrosion. As I discussed, one of the main culprit in the combustion is sulfur, which is present in the fuel, right? And if it is since the solid fuel of our coal is having more amount of sulfur compared to liquid or gas, therefore a chimney concept or the design of the chimney plays very important role. So one more important thing, because it is a tall, lightning conductor has to be incorporated. The type of drought systems. which are the different draught system. One is a natural draught, second one is mechanical draught, third is in the mechanical only we can find forced and induced draught, and the third one is a balanced draught. Let us understand each one in the coming slides. So, natural draught. If you see the given picture, here this is the furnace, and you can notice here no fan anywhere in the system. Is right? There is no fan to give to the combustion chamber, or there is no fan after the combustion chamber. So if there is no fan is there, then I can get a natural draught. And this type of system we can generally see in domestic purposes, right, where we are using the firewood for burning, for taking bath and all. So there we don't provide any fan, so it is used for a small capacity power plant. Surely in megawatt plant I cannot think about natural draught. This may be or may not be sufficient to overcome the losses in the system. So drought is caused by the difference in the weight of column, right? It is due to the buoyancy force, or it is the difference, right, in the density. And if that hot gases has to naturally come out through that passage. So the performance of the system depends primarily on the height of the chimney and average temperature of the hot gases. So if it is the flue gases of what composition it is having and what is the temperature it is containing, that plays a very important role in the natural draught. When the mass flow rate is more, surely I may get the flow, but it may not be sufficient enough to meet the PCB norms. The advantage of natural drought is no external power. Means when there is no external power, my electricity bill, right, the running cost will be surely of lesser quantity. It requires small capital investment. So fans are not there. Therefore, I can think about the fans are not there. Along with the fan, we will get a bearing also, which is more costly. So that capital investment will be less. Maintenance cost is minimum because there is no bearing, there is no routine checking of the bearings or the fan blades profiles and all. So therefore the maintenance cost will be less. The exhausts are discharged at a high altitude, and hence atmospheric pollution is less. The system has a long life because it has no fan. The limitations are the maximum pressure created by the natural drought is very low. We cannot get right. Therefore, I should have a very tall chimney. If I have very tall chimney, that is also danger, because when I'm having a chimney, it has to take the wind velocity, and whether the area is prone to any earthquake, I have to take account of all those things. For sufficient drought, the flue gases should be discharged at a higher temperature, which reduces the plant efficiency, because this will actually increases the global warming. Not only global warming, it is that heat is waste, right? I'm just dumping the heat to the sink, which I don't want. As a thermal engineer, I want to use that heat through means of economizer, by means of aerator, but it is not possible here. The economizer and preheater cannot be recovered sufficient quantity. As I discussed, the system will have poor combustion efficiency. It cannot produce a higher draught, right? 20 mm is has been set. I cannot get more than that one. So that is the main disadvantage of this system. Let us see what is meant by mechanical draft. There are two types of mechanical draft depending on the fan used for creating the draught system. Let us see what are that. One is a forced draft, one is a induced draft. Let us understand what is forced draft by looking into this sketch. In this sketch, it is very clear that actually this is not boiler, this is a fan, right? And boiler or furnace has been shown over here. If I am providing a fan before the furnace and I don't have any fan afterwards, then it is termed as a forced draft. So only one fan, that is also before entering the air entering to the boiler, then they are called as a forced draft fan. So here I only have a FD fan. In this system, a blower or a fan is provided before the furnace. This blower forces the air through the furnace, economizer, air filter, then finally to the stack or a chimney. This system termed as a positive or a forced draft system, since the pressure draft system is above atmospheric and flue gases are force driven. The function of the chimney in the arrangement we have already discussed can be discharged to the high altitude. The chimney has got nothing to do with the draught creation, hence the height need not be too much compared to the natural draught. What is induced draught? Let us understand. If a blower or a fan is introduced after the boiler and there is no fan before the boiler, then these are induced draft system. So this causes air to be induced into the furnace through the entrance port and hot gases flow through the boiler economizer. So the action of induced draft is similar to the action of natural draught chimney, but draught is independent of the temperature of hot gases. There it was in the natural draught we have seen, as the temperature is high, then only it will smooth operation. But here not so. At any temperature, I can create or I can dump the draught, by draught the flue gas into atmosphere. So here in the sketch you can see the blower or the fan is provided after the furnace, right? Only one fan, right? Blower or a fan has been provided after this one, and this create the passage of the flue gas in the system. So that is the main difference of these two systems what we have discussed. Balanced draft. What is balanced draft? A balanced draft is a combination of forced draft and induced draft. Means if I have both the fans, right, FD fan and ID fan, that is called as a balanced draft. So mini boilers in the higher capacity megawatt is a balanced draft system. The forced draft fan provides the entry of the furnace, supplies air to the fuel bed or grate, while induced draft fan sucks the hot flue gases. So individually they are working on to their capacities. So forced draft supplies sufficient air to the combustion, and induced draft to prevent blow of flame when the doors are open. So here you can see in the sketch the FD fan and ID fan, right? So it will be very smooth operation compared to the earlier. So there are two fans. Here you can see the two fans. One is the first one is the FD, second one is the ID. So such a system are very much used in high capacity megawatt plants, right? So one more point is noted is when we are entering to furnace or when we want to check the furnace, we have to take care of the draught before opening the furnace, right? Surely we have to take the engineer permission, right? And monitoring the draught system, right? I can visualize or I can monitor the furnace. Otherwise the flame may come out of the furnace and it is much dangerous. So the comparison between the forced draft and induced draft, right? The induced draft handles higher volume compared to the forced draft. Water cooled bearings or the bearing design or the cost of the bearing of ID fan is are required, which makes the cost a little bit higher. There are chances of air leakage in the FD fan, right? Therefore, it will actually may introduce excess air into the system. In the ID system, the air flow is more uniform through the grate and furnace as compared to the forced draft. Right, the fan blade wear is more in ID fan system, right, because I am handling the dirt, but in FD fan the ambient air is not having the dirt compared to the flue gas. Therefore, the life of the FD fans are much more higher. Advantages of mechanical draft over natural draft. So, as we told, the mechanical draft is the rate of combustion of is high at a higher draft available, and the rate of airflow, right, is controlled by changing the draft pressures. The operation of the mechanical draft system does not depend on environmental temperature. Right? The environmental temperature plays no significant role over here. Any low grade fuel can be easily burned in the mechanical draft. So in mechanical draft, maximum heat can be recovered, hence overall efficiency is higher. The chimney height need not to be high as the natural draft, as its function is only discharge of